Good day, everyone. I am Sharu.
I am Brandon.
And I am Jaden. We are Group 4 and our lab is FC. Today, we will be presenting on our data science mini project. These will be the contents that we'll be covering today. The problem that we'll be talking about today is job hopping. Job hopping is a common trend among younger workers today, as seen in an alarming amount of young people changing jobs on a yearly basis. According to a study conducted by the Employee Benefit Research Institute, over 22% of workers aged 20 and older spent a year or less at their jobs in 2022. This creates a problem for the human resource department in most companies as they are not able to identify potential job hoppers, resulting in them not being able to replace workers quickly or retain them longer, leading to a high turnover rate that could potentially affect business strategy and performance. The dataset that we will be using is a HR employee dataset that we have found on Kaggle. Our goal and motivation is to leverage machine learning and come up with a model to help the human resource department predict which employees are most likely to leave the job based on the data provided in their employee yearly survey, allowing HR to have more time to make informed decisions regarding potential departing workers.
Now, we will talk about our exploratory data analysis on the attrition dataset. First, we will identify the type of variables that we are working with so we can better plan our approach to the dataset. Next, we explore the number of unique values for each variable and discover that over 18, standard hours and employee count had only one unique value. Thus, we will drop them. Next, we looked at any missing values and discovered three variables with 10,225 missing values. These variables are living year, reason, and reliving status. We dropped them not only because they have a lot of missing values, but we feel that they are a result of attrition and hence should not be included in our features. I will now highlight a few key insights from our histogram observations. Firstly, for business travel, we see that employees who travel frequently are more likely to leave. Secondly, for marital status, we observe that those who are single are also more likely to leave. Thirdly, for gender, it is the male counterparts that are more likely to leave. Fourth, those with low income are more likely to leave. And fifth, those who work overtime are also more likely to leave. Lastly, an interesting observation is that people who perform average are more likely to stay, while those who perform poorly or excellently are more likely to leave. Now we explore mutual information scores to identify any independent variables that have no association with attrition. These variables are gender, years since last promotion, education field, and relationship satisfaction. Since we see no association with attrition, we will consider dropping these variables.
During our exploratory data analysis, we also found two types of categorical variable, ordinal and nominal. Ordinal data is data that can be ranked or ordered, while nominal data is data that can be made to fit various categories. The nominal categorical variables include gender, over 18, overtime, stock option level, office code, business travel, department, marital status. Making use of one hot encoder, we were able to transform categorical variables as integers. As for ordinal categorical variables, we have education field and job level updated. When we convert their categorical values into numeric format, the encoding is based on their ordinal relationship to one another. We noted a large class imbalance in the response variable attrition. Through the method of upsampling, we balanced the ratio of the response variable. This will help in our machine learning prediction later on. On to the machine learning portion. As our problem is a classification problem, where we predict whether an employee will leave the company or not, the three machine learning method we will be using is decision tree classifier, random forest classification, and multi-layer perceptron. The first machine learning model we will be using is decision tree classifier. A decision tree is a hierarchical model used in decision support that depicts decisions and their potential outcomes, incorporating chance events, resource expenses, and utility. This algorithmic model utilizes conditional control statements and is non-parametric, useful for classification tasks. The results of our decision tree is as follows. Accuracy rate is the number of correct predictions made divided by the total number of predictions. Our accuracy for our trained data is 0.90 and accuracy for our test data is 0.89. Thanks to the upsampling of the response variable earlier, our accuracy is doing okay. However, we will attempt to increase this accuracy rate even higher using other machine learning methods. The next machine learning model we used is random forest classification. In a random forest classification, multiple decision trees are created using different random subsets of the data and features. Each decision tree provides its opinion on how to classify the data. Predictions are made by calculating the prediction for each decision tree, then taking the most popular result. Two hyperparameters that will affect the result of the accuracy are n estimators and max depth. Setting our two hyperparameters, n estimators to be 100 and max depth to be 7, we achieve an accuracy rate of 0.94 for our trained data and 0.93 for our test data. Other metrics such as true positive rate, true negative rate, false positive rate, and false negative rate are performing much better than decision tree classifier previously. However, one flaw about the random forest is that we have to constantly change and experiment with the two hyperparameters in order to achieve higher accuracy. Hence, to overcome this, in our next machine learning model, we will make use of neural network to help with our prediction. The neural network model we made use of is multi-layer perceptron. The multi-layer perceptron is a feed-forward artificial neural network model that maps input data sets to a set of appropriate outputs. An MLP consists of multiple layers and each layer is fully connected to the following one. The nodes of the layers are neurons with non-linear activation functions, except for the nodes of the input layer. Between the input and output layer, there may be one or more non-linear hidden layers. We were able to achieve excellent results for accuracy rate, precision, and recall using the multi-layer perceptron classifier. Precision refers to the number of true positives divided by the total number of positive predictions, while recall is a metric that measures how often a machine learning model correctly identifies positive instances from all the actual positive samples in the dataset. With our metric showing a promising result of 0.99 for accuracy, recall, and precision, given multiple predictor variables from the employee data, our MLP model will be able to predict whether or not the employee will leave the company or not.
Through this project, we learned how to make use of different machine learning methods, such as multi-layer perceptron and random forest. We also learned a new way of identifying relationships between variables through mutual information. As stated earlier, the main outcome of our project is that we hope to come up with a model that has a high accuracy in predicting attrition of job employees. During this project, we were successful in finding a specific model that tackles our problem statement. As shown earlier, we were able to achieve a higher accuracy using the MLP model at 0.99. Using the model, the HR department will be able to accurately predict and anticipate probable departures of employees with constant yearly updates on their status. For our recommendations, with this information, the HR department can either reach out to them and make an effort to retain them, or start searching for potential candidates to take over these roles. After performing feature ranking on our random forest classification, the feature ranking pointed out variables that will heavily affect the accuracy of the model. Hence, when the HR department collects the employee data on a yearly basis, they have to include these key factors and make sure that these key factors do not have any null values, as they play an important role for our model to be accurate. Once again, we are Group 4, and that's the end of our presentation. Thank you.